Welcome to the reaction intermediates for the first year organic chemistry. Now let us consider first electronic effects. Electronic effects. In these electronic effects, actually we have four effects. The first one is inductive effect. Inductive effect. Second one is electromeric effect. Electromeric effect. The third one is resonance effect. The fourth one is hyperconjugation effect. Hyperconjugation effect. First, let us start with this inductive effect. Inductive effect. When we consider a bond between the carbon and some other group, that group or atom, if it is more electronegative, the electronegativity stands for the capacity to attract the electrons. That's why when you consider a bond between the carbon atom and some other group, X group, if this X is more electronegative than the carbon atom, then the electrons of this sigma bond slightly get displaced towards this X group. So this carbon will then carry slight positive charge, then this X group will carry slight negative charge. So such a displacement of the electrons of the sigma bond electrons due to the difference in the electronegativity is called as the inductive effect. So if it is another carbon atom attached to this carbon atom, the effect will be little less. If there is a third carbon atom, still less. Beyond the third carbon atom, it is negligible. So displacement of electrons of a sigma bond between two atoms due to difference in electronegativity. Difference in electronegativity is called inductive effect. There are two types of inductive effect. In one case, it is called as the minus I effect. Minus I effect. As we have seen here, if there is a group more electronegative than the carbon atom, it will attract the electrons. So slight negative charge is produced on that particular atom. So such an effect is called as the minus effect. Minus I effect. That is, when a group attracts electrons from a carbon atom. It is called minus I effect. There are so many groups which can attract the electrons from the carbon atom. That's why all such groups are named as the minus I groups. And the effect that is actually carrying the negative charge on this and positive charge on the carbon atom is called as the minus I effect. For example, I will write these in the decreasing order of their effects. Suppose you consider this tertiary alkyl ammonium ion R3N+. It is more negative inductive, that is, it will attract the electron because of the positive charge on the nitrogen atom, and it will be more effective than the NO2 group. In turn, it is more effective than the Cn group, Cn minus or Cn group, which is in turn more than the COOH group, more than halogens like fluorine, chlorine, bromine, iodine. Then comes the alkoxy group, methoxy group. Then finally we have this OCH, OH and C6H5. That is, if there is a tertiary alkyl ammonium group, it is having more negative inductive effect than the nitro group, then CN, like that it is decreasing. Phenyl group is also having the negative inductive effect, but it is weak as compared to the various other groups. Then we have this positive effect, plus I effect. When a group pushes the electrons towards a carbon atom, it is called plus I effect. For example, if you consider this oxide ion, O minus, it is having more effect than the COO minus. It is more than the tertiary butyl, CH3 thrice C, which in turn is more effective than CH3 twice CH. This is isopropyl group, which in turn is more than the N-propyl group, CH3 CH2 CH2 group, then CH3 CH2, then CH3. That is, positive inductive effect decreases from oxide ion to the methyl group. Among the various isomeric alkyl groups, higher the branching, higher will be the inductive effect. As compared to N-propyl group, this isopropyl group is having the higher positive inductive effect in the particular thing. Then we have this second one, the applications of these inductive effects. Applications. So using the inductive effect, we can explain so many things. So I effect explains first one, greater reactivity of alkyl halides than alkanes. For example, when we have this CH3Cl, we know that this carbon-chlorine bond is polarized due to inductive effect, and hence it will undergo easily nucleophilic substitution reactions. It is because of the polarity, that is inductive effect. We have that polarity, that's why it will undergo easy reaction. If you compare this reaction with the methane is less reactive. So that can be explained by considering this inductive effect. Second one is relative acidic strengths. Of carboxylic acids. For example, if you consider this CH3COOH and HCOOH, when we consider this acetic acid and formic acid, we can explain which is more reactive, more acidic when we compare one with the other one. First you consider the ionization. It will give rise to CH3COO-. This will give rise to HCOO-, along with the formation of H+H+. But when you consider this CH3COO group, this CH3 group has got the positive inductive effect, plus I effect. That's why it will increase the negative charge on the carboxylate ion. As the carboxylate ion negative charge increases, automatically its tendency to attract this H+ increases. That's why it is less ionized as compared to this formic acid. Formic acid is more ionized because there is no any inductive group. That's why there is no much tendency for this COO- to attract the H+. That's why acetic acid is a weaker acid than the formic acid. The third one is relative basic strengths of amines. Suppose you consider this methylamine, CH3NH2. Compare with this CH3NHCH3. A group carrying the lone pair of electron behaves as a base. That's why this dimethylamine having two inductive groups will be more basic as compared to this methylamine. So methylamine is less basic as compared to dimethylamine. Similarly, when you consider this CH3CH2NH2, ethylamine, since there is only one inductive group, it is less basic as compared to dimethylamine. So relative basic strengths of the amines can be explained by considering this one. The next one is relative reactivities. Relative reactivity of carbonyl groups towards nucleophiles. So these are the various applications of the inductive effect. Using these we can explain the greater reactivity of the halogenated compounds as compared to aliphatic compounds or alkanes, relative acidic strengths of the carboxylic acids, relative basic strengths of the amines, and relative reactivities of the carbonyl compounds. Since this carbonyl compound carries a C double bond O, there is a polarization of this group, C double bond O. That's why the carbon will get slight positive and oxygen will get slight negative charge. Any nucleophile like Cl- can easily attack this carbon atom. So that is explaining relative reactivity of the various carbonyl groups. So this is about the effect called as the inductive effect. Now let us consider this second one, that is electromeric effect. In the electromeric effect, one more information regarding the inductive effect is, it is a permanent effect. It is a permanent effect. That means, when we consider this inductive effect, in the molecule itself there is a polarization even when it is not undergoing any reaction. So it is a permanent effect. Coming to the second one, we have this second one, electromeric effect. Electromeric effect is actually a temporary effect. Electromeric effect, and this involves carbon-carbon or carbon-oxygen multiple bonded electrons. That is, pi electrons are involved. Comparing to this inductive effect, electromeric effect involves pi electrons, while inductive effect involves sigma electrons. And it is a temporary effect. Temporary effect. It is only when a reagent is used in the reaction, then only based on the need of that attacking reagent, there will be polarization of the carbon-carbon or any multiple bond electrons. Suppose I consider this is actually polarization. We can also call it as displacement of electrons, of pi electrons, based on the requirement of attacking reagent. Attacking reagent is called electromeric effect, E effect. So let us consider, for example, when you consider this C double bond C, suppose there is an electrophile attacking this carbon. If this electron density shifts towards this carbon atom so that this H plus can attack to that, this will give rise to the carbon positive charge and this carbon negative charge. This type of effect is called as the minus E effect, plus E effect. This is called plus E effect. It is when electrons, pi electrons shift towards the carbon atom or towards an atom to which that attacking reagent reaches or attaches, is called as the plus E effect. Suppose you consider this carbon-oxygen double bond. When we consider this Cn minus, if this polarization is considered, this Cn minus ion will go to this carbon atom. So that the polarity is carbon this positive charge, this oxygen negative charge. So that Cn minus can easily attack this carbon atom. So this type of effect is called as the minus E effect. When the electron of the pi bond go away from the carbon atom, so that reagent attaches the carbon atom. That is called as the minus E effect. So we can classify the electrophilic groups, electromeric effects as plus E effect as well as minus E effect. When attacking reagent reacts to the carbon towards which electrons are shifted, it is called as the plus E effect. If a reagent attaches to a carbon atom, so that electron goes away from that carbon atom of the multiple bond, then it is called as the minus E effect. And as I told you, it is only a temporary effect. The next two effects we will see in the next videos. Resonance effect as well as the hyperconjugation effects. Thank you.